All right, so tautology is a statement form that is always true. So if we looked at the truth table, the column would only contain T's in it. And a contradiction is a statement form that is always false. So again, if we looked at the truth table, it would only contain F's in the column. So now let's look at another problem that involves a truth table are the statement forms logically equivalent. And my statement forms are going to be P or P and Q and P. Are those things logically equivalent? Well, to determine if they're logically equivalent, we put them in a truth table together and see, are their columns identical? They need to have identical columns. So again, here I have two variables, P and Q. So my truth table will only have 4 rows in it. And now let's build up our first statement form. First column I'm going to make is P and Q. True, false, false, false. And then I can make the whole thing now P or P and Q. So we're going to look at the P column, we're going to look at the P and Q column, and there's an OR here, so we only need one T. True, true, and then false, false. Compare this now that we've got these. I'm going to put my other statement, which is P, over here to the side. And ask myself, are these two columns identical? And they are, so the answer is yes, they are logically equivalent. So again, those columns have to match exactly. So now let's talk briefly about De Morgan's law. So De Morgan's law, remember, tells you how to negate compound statements, statements with ands or ors in it. So remember the way it works. I negate each piece, but I have to flip it. So here it's an and, it's going to become an or. If I negate an or statement, I negate each piece, but now the or is going to become an and. So anytime you negate and or statements, you have to flip those. So let's look at the following example. I want you to negate the statement, the train is late, or my watch is fast. So it might help if we identify our two pieces here. The train is late, my watch is fast. So let's negate it. So you're going to negate each part that I've underlined in red. So let's start. The opposite of the train is late is the train is not late. And then we've got to take this or here becomes an and then negate my watch is fast would be my watch is not fast. And that would be my negation of this statement. So again, the big thing is to make sure that you flip, in this case, the or into an and statement. Let's look at doing another truth table, but now let's look at one that involves a conditional statement. So construct a truth table for not P or Q implies not Q. So again, I have two statement variables, P and Q. So my truth table will have 4 rows in it. So I'm going to start building up my thing in my form in the parentheses. So I need not P first. So you're going to flip the entries in P. And then I need to combine that with an or Q. Let's focus on not P in the Q column. There's an or between them, so it'll be true, false, true, true. Okay. So now I've finished making that thing in the parentheses. I'm also going to need not Q as well. So we're going to take the entries in the Q column and flip them. False, true, false, true. And now we're ready to make our final column, not P or Q, then not Q. So you've got to look at our two columns here. And if you look in the first row, the hypothesis, the beginning part is true, and the conclusion, the end part is false. So this is the only time you would record a false. Then in the second row, the first column is false, and that means it's automatically true. You have another true and false, so that's false. And then they're both true, so that's true. So that would be the truth table. All right, so then remember when we have these conditional statements, we have other conditional statements from that. We have the contrapositive, where you flip them and negate them. You have the converse, where you just flip it. And then you have the inverse, where you just negate and you leave them in the same order. So let's look at an example here, and let's try to find these three statements. So let's say if today is Saturday, then I don't get up early. So what would the contrapositive be of this statement? Well, contrapositive, I switch them and I negate them. So if, maybe I'll underline them in red so you can see the two pieces. So I'm going to take that second piece and negate it, so it becomes if I get up early. If I get up early, then today is not Saturday. What would the converse be? The converse, you just switch the order. So if I don't get up early, then today is Saturday. And the very final one is the inverse. The inverse, which you leave them where they're at, but you negate each piece. So if today is not Saturday, then I get up early.